Hey there, my name is Austin Greene, and if you are watching this video, it's because you have a KiloCam PCB like this guy, and you're probably wondering how in the world you program this and how you actually go about using it. So I have my little Windows laptop in front of me, and I'm going to walk through the entire process of programming a KiloCam PCB, programming the ESP32CAM board that KiloCam uses, and gonna go from zero all the way basically to getting you ready for deployment. So step one is to get all of the parts together, and this is what you need. Now, when you first receive your KiloCam PCB, it's going to look pretty similar to this. You're not going to see any extra wires or anything else. It's just the KiloCam PCB, but all the soldering has already been done for you. And it includes those green screw terminals that you see there, which are used for connecting a power source. In addition to the KiloCam PCB, you are going to need an ESP32CAM development board. These boards are available anywhere online like Amazon or eBay for $5 to $8 a piece, depending on how many you buy at any given time. For that ESP32CAM board, you are going to want a small 16 gigabytes or smaller micro SD card that you're going to use to store your imagery. And to program both the ESP32CAM and the KiloCam, you are going to want an ftdi USB to serial programmer board. Don't worry, it's not as intimidating as it looks. They're really simple to use. Now, to program the ESP32CAM, which you only need to do once per camera, you're going to use the ftdi programmer, and you're going to need 5 female-to-female jumper cables. You'll notice that each end of these cables has a female end, and that's what's going to allow you to connect the pins on the ftdi programmer to the male pins on the back of the ESP32CAM. Now, of course, you're going to need a power source for your KiloCam, and what I would recommend is one of these. This is a 3.7 volt, 750 milliamp hour, that is the capacity, lithium polymer battery. Now, there are special considerations that you should research regarding the use and charging of lithium polymer batteries, but in general, they are an excellent power source that can be had pretty cheap. You can also use lithium-ion batteries or even a modified USB cable if that is an easier power source for you to use in a laboratory setting. But for deployments in the field, lithium polymer and lithium ion work great, and if you can't access those, you could also use 2 or 3 AA's as your power source for KiloCam. So you are going to need a cable or a connector that matches your chosen power source, so today we are going to use this. This cable has the exact same connector that our battery does, and we are going to connect this cable to the KiloCam PCB when we're ready to power it. After you have all the parts together, the very first thing I want you to do is to go online, and I have it up on my screen right now. Go to the Arduino website, which is arduino.cc/en/software, or just go to arduino.cc and click on the software tab and scroll down, and you're going to download the Arduino IDE. Now, if you can, great, afford a donation. That would be great for the people who make Arduino, but if you can't, they understand as well. So download the Arduino IDE for whatever operating system you have. I already have downloaded it because I'm running Windows, and of course, I've already done this before. So after you download and install the Arduino IDE, there are a few more things that I want you to do. The first is to follow the tutorial that's been put out by Random Nerd Tutorials on preparing the Arduino IDE for communication with the ESP32CAM board. Now, I'll put a link down in the description, and basically they do an excellent job at walking you through how to get the Arduino IDE ready so it can communicate with the ESP32. It's really simple. You're just copying, pasting 2 different lines into a preferences tab of the Arduino IDE, but frankly, they do a better job of describing it than I could. So yeah, go follow their tutorial. It'll take you 5 minutes and then come right back.
5 minutes later.
Okay, you're back. That means you have successfully gone through the Random Nerd Tutorials guide on how to set up the Arduino IDE to communicate with ESP32 based devices, such as the ESP32CAM that KiloCam uses. Now, there's one more step we need to do to prepare the Arduino IDE, and that is to install the libraries that we're going to rely on with our code that controls the KiloCam and or the ESP32CAM. So there are basically two ways that you can do this. There's the easy way and the hard way. The hard way would be to go to each of the links that I'm going to put in the description to the different GitHub repositories for the libraries that we need, and you're going to go to those repositories and download the code by clicking this button here as a compressed file. After you have downloaded the code, then you are going to go into the Arduino IDE, click on Sketch, and then Include Library, and then scroll over here to where it says Add.zip library. Point the browser window that comes up to the area where you have that compressed library folder downloaded, and then it will automatically install the library for you. The easier option that I'm going to suggest is to download the file that I'm linking to in the description. This is a compressed file within which you basically are going to get this. This includes, as you see on my screen, the RTClib library, the low power library, the DS3232RTC library. Those are all libraries that we use to program KiloCam and to set its real-time clock. And inside of this folder here called code files, these are the two different code files that we're going to run to program both the Arduino, meaning the KiloCam, and the ESP32CAM board. So when you want to install the libraries that are inside this compressed folder, all you have to do is to select those three folders, DS3232RTC, the low power folder, and the RTClib, and then copy and paste those into the Arduino libraries subfolder within your documents folder if you're on a Windows PC. You know that you have successfully installed a library into the Arduino IDE, and you may need to reboot the IDE after doing this, because you'll go here under Sketch and you'll click Sketch, Include Library, and you will see the library that you installed listed. For example here, DS3232RTC. So there are a couple more libraries that you don't install from GitHub. These are already available here under Tools, Manage Libraries. When you click that in the Arduino IDE, it's going to bring up the Arduino Library Manager. And depending on your PC, this can take some time to load because it's basically cross-referencing the libraries that you have installed with the libraries that are available online. So now that it has updated, I'm going to type in Wi-Fi, capital W, lowercase I, capital F, lowercase I. And you basically can just scroll down a little bit. And if you scroll down, you're going to see this guy right here. And you'll note on my PC, it shows that it's already installed. On yours, it won't. So there should be an installation button right over here to the right. You can just click that to install the most recent version. And that's the last library that we should need to install for all of the programming that we're going to do. So the next step here is to program the ESP32CAM board with the code that will tell this little board to take a photo every time that power to the board is reset. So to do that, go ahead and go into the folder that I included called Code Files. And inside of Code Files, open up ESP32CAM code. Now, there might be a different date stamp there as I update the code, but nonetheless, that is the file that you want. I already have my copy open right here, and the good news is there is nothing in this code that you are going to need to change. You can read through it if you want and see some of the comments that I've put in there. There are things that you can change if you want, but for starters, I wouldn't recommend it. So to upload this to the ESP32CAM, you are going to need 5 female to female, I'll see if I can hold this up to the camera for you, female to female jumper cables, and you are going to wire up your ftdi programmer, this guy, there you go. You're going to wire this up to the ESP32CAM board following the wiring schematic that you see on the screen right now. Okay, so if you're like me, you should now have an ESP32CAM hooked up via 5 female-female jumper cables to your ftdi programmer. Now, really important thing is that on this ftdi programmer, you need to set it to 3.3 volts mode. And you do that by moving this little yellow jumper left or right, and you should see some little letters on the ftdi programmer itself that says basically this side is 5 volts and that side is 3 volts. I already have mine set to 3 volts. The other thing we're going to do now is plug in the other end of our USB cable into the laptop that we're going to use to program. After you have plugged in the USB cable, what you need to do is come around to the back of your ESP32CAM board and press the reset button. Now, by pressing this reset button and by having the little connection here between ground and input-output 0, what that does when you push this reset button is it puts the ESP32CAM into a programming mode. So now it is ready to receive code from the Arduino IDE. If you didn't hit that button, then you would run into a connection error where the Arduino IDE is trying to send the code, but nothing is listening on the other end of the line. So all that's left is to program this thing. So to do that, we come into the Arduino IDE, and right up here, we want to make sure that we have the file open, ESP32CAM code. Again, the date stamps may differ. You're going to come up here under Tools, and it might already be set to something like this, Arduino Pro or Pro Mini. We're going to use that later. But right now, you're going to come over here, and you're going to go down to ESP32 Arduino. And then you're going to scroll down until you see AI Thinker. A little ways down here, there we go. AI Thinker ESP32CAM. Go ahead and click on that. And go back up here to Tools. Now what you'll notice is my laptop is recognizing that I have something plugged in to COM port 4. That is the FTDI programmer. If your laptop is not recognizing your FTDI programmer, you may need to install some drivers. I'll put a link in the description for a tutorial or some FAQs for common problems with that sort of stuff. It does come up especially on Mac machines, but on this PC that I have, it seems to recognize it right off the bat. So the important thing is that I do have something there in the COM port that the Arduino IDE recognizes. Otherwise, it wouldn't know where to send the code. All that's left now is to come up here in the Arduino IDE and hit upload. Now, you may get a warning like I just did. Basically, it's saying, oh, the sketch folder has disappeared. That's because I moved some files around. You will probably get a warning when you first open the ESP32CAM code, and it's going to tell you that it needs to be inside of a folder in order to run. Just say yes, it'll make a folder for you. What you'll notice when you hit the upload button like I did is first it's going to need to compile the code. Depending on how fast your machine is, and this little tiny laptop is quite slow, the compilation can take some time. Give it a minute or two and it should run just fine. After it's done compiling, it will then try uploading. So I'm going to, through the magic of editing, fast forward to that moment. Okay, so we're nearly finished compiling here, and it's about to upload the code from the Arduino IDE to the ESP32CAM. Now, the important thing to look for in the Arduino window, you'll see down here on the bottom, it will tell you connecting, and it will tell you if it established a connection. It looks like it might be having a hard time, so I'm going to hit the reset button on the back of the ESP32CAM one more time. And there we go. It established a connection, and now it says that it is writing the code to the ESP32CAM, and we can confirm that by the lights on the FTDI programmer just kind of blinking intermittently, about maybe once every second. When it's done, it will tell you on the Arduino IDE, done uploading, and it will say down there in the terminal, leaving hard resetting via the RTS pin. That's the reset pin. So at this point, we have now programmed the ESP32CAM. We can ditch these female jumper cables because we won't need them again. And we have a fully programmed ESP32CAM that is ready to go onto a KiloCam board. That's all we need to do on this guy. Now all that's left is to program our KiloCam board, and that comes in 2 steps. First, we're going to program the real-time clock. Then we are going to program KiloCam to do whatever we want in terms of capture time of photos. So very first thing you're going to see on the screen is that I have closed out the ESP32CAM code and I have opened up the KiloCam code. You'll see that up here at the top. Now, you're not actually going to use this just yet. First, like I said, we're going to program the real-time clock. So go up here under File, go to Examples, and scroll down to where it says RTC lib. Now, there are a couple options here. The first one that I'll point out to you is set time. If you use this example and if you upload this code to KiloCam, then it is going to basically take the time on your laptop and use that to program the real-time clock to set the clock on KiloCam. Now, there's always going to be some amount of delay. It might take 30 seconds for the code to compile, and that means the time on KiloCam will be 30 seconds off, in addition to any error or however far off your computer's time might be. So those are things to keep in mind if you're trying to get multiple KiloCams to simultaneously take photos. What I prefer to do is to do this code, which is set time serial. What this does after we upload it, we don't need to change anything in the code, is we are basically going to upload this to the KiloCam via the ftdi programmer, and then we're going to open up a serial monitor window here on our laptop. It's already part of the Arduino IDE, and we can just type in the code that we want to set the KiloCam to. And this is really useful because you can get many boards synchronized to each other this way by just setting them all to an accurate time using an accurate time online like time.is or something like that. So first things first, we are going to go up here under Tools, and we're going to change the board because we're no longer programming an ESP32. We are programming what is the equivalent of an Arduino Pro Mini. So under Board, go over and select Arduino AVR boards, and then scroll over right here, and it says Arduino Pro or Pro Mini. After you select that, click on Tools one more time, and you want to make sure that you have this option selected, 3.3 volts, 8 megahertz. If you don't select that, you're not going to have a properly working KiloCam. Lastly, I still have my ftdi programmer plugged into my laptop, and it is still detecting it over the port. Very important, or none of this will work. At this point, we are ready to upload this code. You connect an ftdi programmer to KiloCam in a really simple way. There are little words and letters right up here behind the pins on your ftdi programmer. Those pins are all labeled, and on the back of your KiloCam PCB, you know it's the back because there's the little battery holder here, there are matching letters that match the pins on your ftdi programmer. So all you're going to do is to take your ftdi programmer and you're going to line up the correct pin with the correct hole here on the back of KiloCam. So mine line up just like this, and yours should too. And then all you're going to do is kind of hold it in your hand like that, firmly pressing these boards against each other, so that way you have a nice consistent connection between the two. Now, just like before, your jumper here should be set to 3 volts, should be set to 3 volts pretty much always for KiloCam or for programming the ESP32. Now, in the Arduino IDE, all we're going to do is hit upload. We are uploading now, and you know that we're uploading because, again, the lights on your ftdi programmer are going to blink real fast, and that means that it is successfully communicating back and forth between the laptop and the KiloCam. It says in the Arduino IDE that we are done uploading, so we're going to come up here under Tools, and we're going to hit Serial Monitor. Now, inside the serial monitor, you might need to change your baud value here. You see how it's kind of just gibberish? Change it to 57600. And if you want, clear the output. So what it's doing right now is it's reading back the real-time clock time. But since we haven't set it, we need to do just that. So you're going to type in the year. Right now it is 2021. And the month. And then the day. Today is the 19th. And then you're going to set the time for the real-time clock. So first comes hours. And this is in 24-hour format. So it is 7 p.m. here, 1900 hours. 02, and because I'm not being too picky right now, I'm just going to enter 0 for the seconds. Again, if you want to get multiple units down to the second synchronized with each other, use an online atomic clock or something like that to make sure that you have the most accurate time possible. Once you've entered this, just hit enter, and it says right there in the serial monitor, setting time, and then you can see it reading back the time to you. So I can see right now that it is reading back the correct time. That's good. You can set this down. You can take the KiloCam off, but remember how you connected it, because we're going to do that in just a minute. We now have a KiloCam with a set and programmed real-time clock, but there's no KiloCam code on this guy yet. That's what we're about to do. So in the Arduino IDE, I'm going to close out the set time serial code. We don't need that anymore, and go to the KiloCam code file. Now at the top of this file, there are all sorts of instructions. I go like in depth about all the different ways you can change some numbers in this script. But to get started, you don't need to know any of that. If you scroll down just a bit, you're going to find this chunk right here that I'm highlighting in the Arduino IDE. The first number that we need to talk about is this, alarm interval. Alarm interval is the number of seconds that's going to occur after KiloCam first wakes up, and this is the interval between photos. So right now, 60 seconds, KiloCam is going to take a photo every minute, as long as some other conditions are satisfied. If you want a photo every 5 minutes, you could set this to be 300. If you want a photo every hour, you could set it to be 3,600. And if you want a photo every 24 hours, I believe it's 86,400 seconds that you could set this to. But for now, I'm going to leave it to a photo every minute. Keep in mind that how often you take a photo is going to impact your deployment time and your battery life of KiloCam, so plan accordingly. If you're taking a photo every minute, include enough capacity in your power source to allow for that. The next number we're going to look at is dawn and dusk. These are basically limits that we're putting, and these are 24-hour values, so from 0 to 24. So right now, KiloCam, when it wakes up to take a photo, because it's always in a low sleep state, if the time is outside of the time period between 6 a.m. and 6 p.m., 6 and 1800 hours, it will not take a photo. It will just go right back to sleep. However, if it is 6 a.m. or 7 a.m. or 8 a.m. or 9 a.m. or 4 p.m. or 5 p.m. or 6 p.m. or any time between those hours, it will take a photo every minute as it is scheduled to do. So this is useful because KiloCam doesn't do that well in dark environments or at night. Rather than wasting battery and wasting memory card storage space, you can just input the hours for dawn and dusk. These can be approximate, and KiloCam will only spend the energy and electricity and battery capacity to take a photo if the wake-up period occurs within these 2 hours. So the very last thing that you need to program your KiloCam is right here. Down here on this line, and I'll highlight it for you, this is where you set the initial wake-up time of KiloCam. And there's some details on this at the beginning of the code file up there in the instructions, how you can change this to not necessarily be a time and to be instead a given day of a month, for example. But right now, this is a time. And right now, this time is programmed to 6 a.m., 23 minutes, as I have highlighted on the screen, 10 seconds. And you can ignore this last 0 here. If I wanted KiloCam to wake up, it is now 7:11 p.m. my time. If I want KiloCam to wake up tomorrow morning at 8:35 a.m. and 15 seconds, then I can set it to look like this. Let's simplify things a little bit and just say 8 a.m. With our current settings of 8 a.m., KiloCam, since it's 7 p.m. my time, is going to sit in a sleep state until 8 a.m. tomorrow morning, at which point it's going to wake up and start taking photos every minute, as I've highlighted here, until it reaches 6:59 p.m. tomorrow evening. At that point, it's going to go into a low power sleep state again until 6 a.m. the next morning, and every day thereafter, it will maintain those boundaries of 6 a.m. and 6 p.m. based on what we've programmed here. So that is all the code that you need to adjust in the KiloCam code. It's well commented, so feel free to read through and learn more about how KiloCam works, but that's all you need to do for now. All that's left is to take this code and upload it to our KiloCam board. So just as before, go under Tools and just make sure that you are still set to Arduino Pro or Pro Mini. You should be, since you just programmed the real-time clock on this thing. Make sure you're set to 3.3 volts and 8 megahertz for the ATmega 328P, and that you have something showing up on your COM port that should be your ftdi programmer. Just like before, take your ftdi programmer and plug it in to the back of your KiloCam PCB and hold it firmly in place with your fingers. However you want, it's gonna look a little weird. Then, as we see here in the Arduino IDE, just come up and hit upload. You will know that it is properly uploading when the lights over here on your ftdi programmer are flashing quickly, the exact same as they were earlier. And when they have finished, and when you see here in the Arduino IDE that it says done uploading, then you know you're good to go. So at this point, we have a fully programmed KiloCam, and we have a fully programmed ESP32. All you need to do is connect a power connector of your choice. In this case, this is the power connector that matches the lithium battery that I'm going to use to power this. This is a 3.7 volt, 750 milliamp lithium battery. You can use anything from 3.3 volts all the way up to 8 volts to power a KiloCam, but I recommend something like this. Of course, it is a li-poly battery, so be careful when charging and deploying these, especially in hot environments. If you are concerned, or maybe you can't get these shipped to you because there are shipping restrictions, then you can also use things like a AA. Rechargeable AA's have fantastic capacity. You could also use a lithium-ion battery like an 18650, which are the same batteries that run in Teslas and stuff like that. All you're going to do is take a power connector that matches your chosen power source, and you're going to connect it to the KiloCam through the screw terminal here. Now, when you're connecting it, there we go, all you want to make sure is that the red positive wire goes over here on the right-hand side when you are looking down at the board, and that the black ground wire goes on this side. So basically just unscrew these screw terminals, slide in the cable, and then screw that screw terminal down. When you're done connecting your power cable, it should look something like this. Again, with the red positive wire over here to the right and the black ground wire over here to the left when you're looking at the PCB. Give it a tug test, make sure that those wires aren't gonna become dislodged when you have this thing out in the field. And all that's left now is to connect your ESP32 cam to your KiloCam. And that's the simplest part. You just take your ESP32, it's got these male header pins, and you're gonna line the two boards up just like that, and just snap them together. That's it. So at this point, you have a fully programmed and ready to go ESP32 plus the fully programmed and ready to go KiloCam board that is controlling it. And all you gotta do is connect via your power connector here to your chosen power source. I have myself a little lithium polymer battery here. So I recommend using something like this with keyed connectors so you don't accidentally swap the polarity. I'm gonna connect these two. And when I do, you're gonna see that this little LED comes on the front of the ESP32. That is the KiloCam running a demo cycle and taking a photo. So there's power going to the ESP32 board right now. It's taking a photo, and then power to the board is cut. At this point, the KiloCam board on the back has entered a low power sleep state, and there is no power being consumed by the board on the front. So KiloCam is going to sit, as we have programmed it, until 8 a.m. tomorrow morning, its initial wake up time. It's then going to start taking photos every single minute until 6:59 p.m. And then the following day, it will take photos every single minute from 6 a.m. to 6:59 p.m. as programmed. And it'll just keep doing that until it runs out of battery. One quick note that I will say before closing this out is that if you want, between deployments, you can reset the file numbering of the photos on your card. So let's say you have just finished a deployment, you take your KiloCam and you disconnect the battery. Then you're going to remove the memory card from the KiloCam, and you're gonna pop it into your laptop like I am right now. So going to our laptop, we can see that we have a memory card full of photos. There's me at my desk and some test photos that I took outside. But up here, there's a text file, and this file says image counter. If you open this up, this shows us that there are currently 31 images stored on this memory card. Now, if you want to reset the image counter, you can just take this file and delete it. That's all you need to do. Totally okay, it's not gonna hurt anything. If KiloCam sees that a text file isn't there, it's just gonna write a new one. You might also too, like right now, I'm going to select all these images and maybe download them first, but since these are junk images, I'm gonna delete them. After I've cleared out the memory card, I'm going to properly eject it. And I'm just gonna drop this memory card right back into the top of my KiloCam. This board now, next time that it's provided power and deployed out in the field, it's going to restart numbering from image 1 all the way out to however many images it takes before you recover it. With that, I'm going to put a photo up on the screen right now showing how you can pack a KiloCam with a battery into a GoPro housing. There are, of course, lots of other options of how you can pack a KiloCam for deployment. It's going to depend on where you put it. I think that's all I got for you guys today. I know this was a bit of a long one, so thank you for bearing with me. And if you are some of the people who are helping me beta test and field test this, I really, really do appreciate not only your time, but also your expertise. I am curious to hear back how this has worked out for you and also the ways that it hasn't, because I'm going to use that information in the future to guide revisions to KiloCam and maybe to develop the next version of KiloCam. With that, I'm Austin. This has been a long one. It's almost 8 p.m. my time, and I'm gonna head home. So that's Real World Science, classic work-life balance here. I will see you guys next time.